As a site engineer, your heart stops the moment you spot a crack on a newly cast wall or column. Your mind immediately races. Is the building failing? Did the contractor mess up the mix? Am I going to get fired by the project manager? Take a deep breath. Not every crack means a structural failure. In fact, 90% of the cracks you see on site are completely harmless superficial defects. But as the engineer in charge, you cannot afford to guess. You need to know the exact difference. In this video, I will show you how to accurately differentiate between a harmless plaster crack and a dangerous structural crack in seconds, using real site examples and practical tests you can do on site. Let's start with Category 1, non-structural cracks. These cracks only live on the surface. They do not affect the load-bearing capacity of your building. The most common type you will see is hairline or crazing cracks. These look like a fine spiderweb on the plastered surface. Why do they happen? Usually, it is because the plaster mix had too much water, or the curing wasn't done properly under the hot sun, causing the surface to dry out way too fast. How do you fix this? You don't need to break the wall. Simply scrape the paint, apply a high-quality acrylic crack filler paste, let it dry, sand it smooth, and repaint. Easy. The second major surface issue is a separation crack. You will see this as a perfectly straight horizontal or vertical line exactly where your brickwork meets a concrete column or beam. This happens because concrete and bricks expand and contract at completely different rates when the temperature changes. The remedy? Prevention is key here. Before plastering, always ensure the contractor installs a 300 mm wide chicken mesh or fiberglass mesh over the joint, split evenly, 150 mm on the concrete side and 150 mm on the brick side. If the crack has already happened, groove it out into a V shape, fill it with a flexible polyurethane sealant, and plaster over it with mesh. Now, let's talk about Category 2, structural cracks. These are your red flags. They mean the structure is under severe stress, overloading, or the foundation is settling irregularly. If you ignore these, you risk structural failure. First, look for diagonal cracks near doors or windows. If you see a thick crack shooting upward at a 45-degree angle from the corner of a window frame, this is a clear sign of foundation settlement or a missing lintel beam. The masonry is cracking because the support underneath has sagged. The remedy? For minor settlement, you must stop the movement first. We use a process called underpinning to strengthen the foundation below, or we insert a structural steel lintel angle above the opening to transfer the load before repairing the masonry with polymer-modified mortar. Look closely at your beams. A 45-degree diagonal crack near the support or column junction of a beam is a massive emergency. This indicates a shear failure. It means the beam cannot handle the cutting forces, usually because the stirrups, your shear reinforcement, are spaced too far apart or are insufficient. The remedy? Do not try to patch this with cement. Inform your structural consultant immediately. The standard engineering fix here is section enlargement or carbon fiber wrapping. Wrapping the beam in carbon fiber sheets acts like an external structural bandage, drastically increasing its shear strength. Finally, check your columns. Horizontal cracks in a column mean it is experiencing heavy bending moments or tensile stress, trying to pull the column apart on one side. Even worse are vertical cracks in a column. Vertical cracks mean compression failure. The concrete is literally crushing under too much weight. The remedy? For columns, we perform concrete jacketing. We chip away the weak concrete, place a new cage of high-strength steel rebar around the existing column, and pour a micro-concrete or self-compacting concrete jacket to increase its load-bearing area. When you walk up to a crack on site, don't guess. Use this exact 3-step test checklist to identify it instantly. Step 1 is the width test. Take out your crack width gauge or a standard ruler. If the crack is less than 1 mm wide, it is almost always a plaster crack. If it is wider than 2 mm and growing, treat it as a structural issue. Step 2 is the chisel test. Take a small hammer and chisel. Carefully chip away a 50 mm patch of the plaster right over the crack line. Look inside. Did the crack stop at the plaster layer? If the brick or concrete behind it is completely smooth and solid, relax, it's just a plaster crack. But if the crack cuts deep into the concrete beam or splits the brick in half, it is structural. Step 3 is the telltale glass test. If you are unsure if a structural crack is still moving, take a tiny, thin piece of glass. Stick it flat across the crack using strong epoxy glue. Write the date on the wall next to it. Come back in 2 weeks. If the glass is still intact, the crack is static and safe to repair. If the glass has snapped into 2 pieces, the building is actively moving, and you must call your structural engineer immediately. As an engineer, always back up your decisions with data. For structural concrete safety limits, refer to IS 456. To deep dive into causes and monitoring of cracks in buildings, read IS 2212 and SP 25. Knowing these codes makes you look incredibly professional in front of your clients. If you found this guide helpful, hit that subscribe button. Leave a comment below telling me, what kind of crack are you currently dealing with on your construction site? Until next time, keep building safely, keep learning, and I'll see you in the next video.